और सुबह से हम ये वॉल को ठेल रहा हो, आई एम पुशिंग द वॉल, द वॉल इज नॉट मूव एट ऑल, नथिंग, नॉट एल्स। सुबह से 1 घंटा काम हो गया, हमने कोई काम किया, पेमेंट मिलेगा हमको? नहीं मिलेगा। क्यों? लेकिन मिलना चाहिए, सुबह से हम काम कर रहा है, हाथ टूट गया। लेकिन साइंस में बोल रहा है क्यों कुछ काम नहीं, क्योंकि वही है डिस्क्रिप्शन देना है। चलो स्टार्ट करो। वेलकम माय टू हेलो गाइस, वेलकम टू माय चैनल स्टडी हब। टुडे आई विल डिस्कस अबाउट द क्लास 9, द न्यू पार्ट ऑफ द क्लास, फर्स्ट पार्ट ऑफ द क्लास 9, work, energy and also power. Okay, this is the class 9 chapter. So let's start. So today work. So what is work? Actually देखो, see, the intuitive meaning of work is quite different from the scientific definition of work. What I see, but what I get from the Newton's second law of motions, we see motion of an object when the force acting on it is constant. But in most physical phenomenon, it is quite different. That is the force and energy, the link. In day-to-day life, the word work means any kind of physical and mental activity. Clear? Physical and mental activity. For example, I am reading a book constantly with high intense mind. I am doing a problem, a critical problem I am thinking, and at last I solve. Cooking a food, holding weight without moving, holding weight without moving. Walking on a road with a box on head, obviously frictionless load. Pushing a wall, what I before show you at the beginning. But in all these cases, according to scientific definition, you or we are not doing any work. Okay, all these things, reading, cooking, holding without any moving, holding weight without moving, all these things, according to the scientific point of view, we are not doing any work. Okay, so what is the scientific concept of work? What is the scientific concept of work? What are the conditions so that we can regard it, this is the actual work? Like, so that is this, suppose a force, the only two conditions required. That means a force must act on the body. A force must act on the body. I am acting the force on the wall. The second case is that object is displaced from it. Okay, on from its own original position. Object have to be moved. If I acting the force, see out here, I am acting the force and object is to be moved. That's why scientific work is to be regarded. Suppose pushing, I am pushing an object and this object moves out here. Pushing an object and direction of the motion of the object with the direction of the force, that is, it is displaced, so direction is changed, place is moving, so this is work is done, magnitude and direction it has. lifting a body. I am lifting. This is out here. I am lifting it. It is the work. Pushing, pulling. I am pulling something. Pulling a trolley. Something. I am. Force is acting. Force is acting, and also displacement is taking place with reaction to the force. Okay. This is a. I am kicking a football. Kick football. Hitting a ball with bat. All is because displacement is taking place. So let's start factors on which work done depends. Two factors are there. You must magnitude of the applied force. Magnitude of the applied force. Magnitude of applied force. One factor. Factor 2, distance traveled by the body. Distance traveled by body. What is this? Magnitude of the applied force means one magnitude of force. If I apply force, applied force is slow, less, the displacement will be less. That is W varies as force, that is the F. Less force will be applied, less work will be done. More force will be applied, more work will be done. And in that case also, it is also work varies as S. S is the displacement. Suppose if I in carom board, force applied, displacement is high, that means work is high. ज़्यादा displacement होगा, ज़्यादा work होगा. कम displacement होगा, कम work होगा. Clear? Okay? So that is W varies as F and W varies as S. So in this case, what we get? W varies as Fs. W varies as Fs. I am coming. Okay? Okay? So next, work done by a constant forces. Work done by a constant force. How will give an example? Work done by constant forces. Constant force is applied in the horizontal directions. That is, this is the block A. This is in the horizontal. This block A. Okay. This is the displacement out here. Force is applied out here. Force is applied out here. Okay. And displacement after applying the force, the block is out here. Okay. It is the direction of force, and the displacement in the same direction. That is the same direction. It is a positive work. I am applying when a force, constant force is applied in the horizontal direction. Okay. So in this case, the movement, the displacement of the body is in the same direction of the force, and it is regarded as the positive force, or positive work. Positive work. Clear? So it is the positive work, same direction. And in this case, what is the work done? Then W equals to F into S, force into displacement. Force into, it is the product of the magnitude of force and distance travelled. The work done is the product of magnitude of force and distance travelled. Clear? So in this case, second condition, when force is acting in a direction opposite to the displacement. Force is acting opposite to the direction but displacement. Force is acting in a direction opposite to displacement. When, what is the example opposite to displacement? Suppose I am applying the force out here. I am applying the force out here. This is the frictional force. Body is out there. I am applying force. Body is moving towards this. But it is against the frictional force. Frictional force opposes the motion. Frictional force opposes the motion. Frictional force opposes the motion. Clear? This is the acting opposite to the direction of the force. Body is moving, but it's against the direction of the frictional force. The second example, when a body is lifted upwards, it is the direction opposite to the gravity. So it is the negative force. In this, what is this? It is the negative force, V. Negative work. Negative work. It is against the gravity. In case of one example is there, negative work, the opposite against the displacement. So tug of war. In the tug of war, what in the tug of war? His force is applied out here. This is force is applied out there. This is team A. This is team B. What happens out there? That is the winning team. That means I am exerting the force in these directions. So displacement will have to be in this direction. But the losing team, the team who lost, who defeat, the tug were displaced to the opposite to the force applied. Where is this? This word is displaced to the direction opposite to the force. I am acting the force in this direction, but rope is going to this direction. So this is the example of the negative force. Tug of war, thrown up body upwards. Okay, all these things against the friction, force is frictional, against the frictional force, all are the negative force. Next, when the force is acting perpendicular to the displacement. Perpendicular to a displacement, that means suppose when a body is there, it is the body, force is acting, I am holding a weight in my head, okay, and I am walking in a frictionless road in this way, okay. So in this case, what is happened? There is no displacement in the direction that is parallel to the force. Force is there, displacement is there, force is there, displacement is there. So these are perpendicular to each other. Okay. So in that case, I will also discuss in later the theta also. In that case, no work is done. That is W equals to F into S, that is F into 0. No displacement. Direction displacement in the direction of force is 0. In the direction of force is displacement 0. It is parallel and is perpendicular to each other. In that case, S equals to 0, so W equals to 0. So force is acting perpendicular to the displacement, the force is 0. And next very important thing, when the force is applied at an angle with the horizontal direction, that is obliquely, okay, okay. So let the figure, suppose this is a block, okay, this is a piece of block, and we are at a certain angle. It is, suppose at certain angle it is drawn, pulling a trolley, a toy, a child pulling a toy, okay, with a chain, with a rope. So in this case, what happens, see out here, that is oblique, so this is the object, I am pulling out the air in this way. Object will move in this way horizontally. The force is applied at an angle with the horizontal direction, but body will move in this way. This body will move in this way out here. It will move in this way. What is in this case? What will happen? In this case, we cannot use W equals to Fs. Remind it. This is theta. W equals to F into S. This formula actually we cannot apply. When at angle it will acts, because to calculate the work done, W equals to Fs cannot be calculated, because S displacement is not exactly in the direction of the force. The displacement is not exactly the direction of the force. The direction of the force is in this way, but body is not moving in this way. The body is moving in the horizontal way. It is not exactly in the direction of the force. That's why we cannot use this formula. Here, this force, this is the force. This force, in the physics you will learn, it will have two components. One is horizontal components, another is vertical component. Okay, horizontal components by horizontal directions and vertical by upward directions. That means here this F will divide it in two components, horizontal and vertical, upward, and it will known as F cos theta and it is F sin theta. ये कैसे आएगा? cos theta sin theta क्लास 10 में है, cos sin tan trigonometry में. I have already discussed in the chapter. Look in the description box. Okay, out there. So F cos theta and F sin theta, these two components acts in there. The F sin theta does not produce any displacement, the block, in upward direction. So only the force F cos theta displaces the block S, displaces the block. So in that case, it does not help, it does not produce any displacement in the upward direction. This F cos theta only helps to produce the displacement of the body. So in that case, W equals to F into cos theta into S. It will be Fs cos theta. The W equals to Fs cos theta. Fs cos theta, we can write it F into S. The dot product of Fs, and it depends upon the theta. If theta equals to 90 degree, if the value of theta, that is perpendicular, I have earlier told, theta equals to 90 degree, then cos theta, cos 90 we know equals to 0. You have to remember it, cos 180 degree equals to minus 1. So if a block, it is in the perpendicular to each other, what I told, if the theta is 90 degree, no work is done. That is, if 90 degree, so no work. क्योंकि W equals to Fs cos theta, cos 90 degree equals to F into S into 0, it is 0. In case of 90 degree, the work done is 0. In case of 180 degree, negative work, that is minus 1, it will be 1. In case of cos 180 degree, it will be minus 1. So the work done is minus Fs, minus F into S. Okay, in case of negative work. Okay, next, last moment I am doing, because I have to go, so I am doing a quick, but I will not go further. So we have reached at the last end, the last discussion, today's discussion last. Okay, see, the question is that when a stone is rotated in a horizontal circular path. When a stone is rotated in a horizontal circular path, in that case, what is the work done? What is the work done? Okay. So, see out here, the horizontal rotating path, stone is moving out here. Okay. So, suppose this is F and it always go to the tangent. Okay. So, displacement is this. What is this? The force acting on the stone. The force acting on the stone, is always towards the center. Acting on the stone is always towards the center. Okay. That is towards the circular path. Okay. Always towards the circular path. This force is called the centripetal force. Again, I am telling the force acting on the stone is always towards the center of the circular path. And this force is known as the centripetal force. This force is known as the centripetal force. Okay. Since the stone is displaced from one position to another position, displacing always of circular path, okay, at right angle. So it is at right angle to the force. Whose right angle? To the force acting on the stone. It always acts right angle to the acting on the force. Since the stone is displaced from one position to another position of circular part at the right angle to the force acting on the stone. So, work done on the stone is in this case is W equals to Fs cos 90 degree. Fs cos theta, Fs cos 90 equals to what? 0. So, in this case, work done equals to 0. So, when a stone is rotated in a horizontal circular path, the work done is 0. Clear? Okay. So, what is the discussion out here? What we got? The force, the work is of mainly 3 types. It is positive work, negative work, and also zero work. When no displacement, that is displacement is 0, that is S equals 0, it is 0 work. Positive work done in the same direction to the horizontal path. In tug of war, you can notice tug of war, both negative work also done and positive work also can be observed. In case of the winning team, it is the positive work. In case of the defeating team, it is the negative work. Okay, applying force along the direction, the defeating team is positive, is negative work, and the winning team is doing the positive work and also zero work when no displacement is occurred at theta equal to 90 degree. And next comes the last portion, the unit of force. What is the SI unit of force? Unit of force, what do we, unit of work, unit of work. What do we observe? W equals to F into S. What is the force? The unit of force, Newton, and unit of displacement, distance travel, that is the meter, that is Newton meter. SI unit of work is Newton meter. Clear? And it is also known as joule. Joule. The British scientist, to give him honor, the British scientist James Prescott Joule, on his name it is given the name the joule. Newton meter also called joule. Clear? So what is the definition of joule? So from here you can define the joule. In case of 1 Newton force is applied, 1 Newton force is applied, 1 Newton force is applied on a body, and it displaces in the direction of force is 1 meter displacement, and 1 Newton force is applied, 1 meter is displaced. So it is known as Newton meter or joule. So 1 joule is the work done when 1 Newton force is applied to displacement of 1 meter. It is known as 1 joule. Clear? So this is the end. Thank you, my students. I will discuss the energy in the next video, and now good night, goodbye, and I request you to share and subscribe my channels and share this video to your favorite friends. Goodbye.